Okay, we are going to continue with solving by factoring. So the warm-up on part A, it wants you to just distribute the -3 to everything that's there. So you're going to have that, and that's your answer. On letter letter B, you can either use box method or FOIL. I'm going to use box method just so it's very clear what I'm doing. So I'm going to put the x plus 4 up at the top here, and then I'm going to put the 2x minus 3 on the side. And then I'm going to multiply the outside portions of the box to get the inside portion. Okay, I'm going to write everything out that's in the box in the order that I see it. Whoops. And then you're going to combine your like terms. So I can combine the 8x and the negative 3x. And that gives me a positive 5x. And that would be my answer. Okay, so that's just kind of reminding you how to multiply different things out. This next type of factoring is used when you have many terms. So usually factoring, we're going to focus on what's called a trinomial. Tri means that it has 3 terms. So something like what you see down here, that's a trinomial because it has 1, 2, 3 different terms. The one that you see on the first example, we're going to factor it a little bit differently because it has so many terms. I'm going to zoom in. There's a little typo here, so I'm going to change the +8 that's here to a 12. Just because I wanted to show you something specific. So I'm going to group this off into groups of 2. So I'm going to split it down the middle. And then I'm going to take out the greatest common factor on both sides. The greatest common factor is the largest number that you can evenly divide out of both terms in your group. So for example, between 2x to the third and 6x squared, the largest number that evenly divides out of 2 and 6 is 2. And then the highest power of x that I can take from both is an x squared. I can't take an x cubed from both because if I have x squared and I want to take an x to the third power, I'm in debt 1x. I don't have that x to give, okay? So then you're going to divide each of your terms by the greatest common factor, 2x squared. So you're going to do 2x cubed divided by 2x squared. So the 2's cancel. And then you're going to subtract those exponents. So this is the same thing as x to the 3 minus 2, which is x to the first, which is just x. So here I'm going to put x. And then I'm going to do 6x squared divided by 2x squared. 6 divided by 2 is 3, and those x squareds are going to cancel. So you're going to get x plus 3. On the other side, the largest number that divides evenly out of 4x and 12 is 4. I can't take an x from both of them because the 12 doesn't have an x attached to it. So the only thing that I can take is a 4. So 4x, do it over here, divided by 4 is just x. And 12 divided by 4 is 3. Okay, so if you've done this correctly, this method will always give you matching terms inside of the parentheses. The matching term is one of your factors. So one of my factors is x plus 3. The other one is the two greatest common factors that you took out. So those two things that I'm circling in red. So you have 2x squared plus 4. Okay, so looking at that factored form, this is the same thing as what's above that long thing with 4 terms in it. It just looks different. It's in a different form. Okay, so here's another example of something that's more similar to like what you'll see on a test. Let me erase the dots. So this is called a trinomial. This has 3 terms. My A value is 1, my B value is 4, and my C value is 3. So to factor this, I'm going to use the box method, or you can use the same double distribution. I'm going to do it both ways, and you can pick whichever one you like. So first thing, we're always going to draw an I. At the top of the I, you're going to put A times C, and at the bottom, you're going to put B. A times C is 1 times 3, which is 3, and B is 4. So I need 2 numbers that multiply to give me 3, and add or subtract to give me 4. 3 times 1 is 3. 3 plus 1 is 4. So I'm going to make the box. The very first term that you see goes in this corner. The very last term goes in this corner. And then the 2 factors that you found go in the diagonal corners. Okay, then you're going to take out the GCFs along the tops and the sides, like this. Okay, so the largest thing I can take from x squared and 3x is just a single x. The largest thing that I can take from an x and a 3, they don't share anything. If they don't share anything, the only thing you can take out is a 1. So just put plus 1. 1 goes into everything. You can divide everything by 1. I can, from an x squared and an x, I can take a single x. And then from a 3x and a 3, I can take a 3. So my factors come from the top and the side of the box. So you've got x plus 1 times x plus 3. If I wanted to solve this, I would set it equal to 0, and I would take both of those factors and break them apart and set them equal to 0, like this. Then I would solve for x. I'd subtract 1 on both sides here. So I get x equals -1, subtract 3, I get -3. If I wanted to write these as a point, I'd have -1, 0, and -3, 0. If you wanted to do this with the other method that's called double distribution, it's pretty much the same process, except there's no box. So the 3 and the 1, I'm looking here, when we drew this I, the 3 and the 1 that are there, that's what this middle term gets broken into. So you're going to have x squared, but then this 4x is going to get broken into plus 3x, plus 1x, and then plus 3. So that middle term gets broken into the 2 numbers that you found in your I. So then you're going to break it into 2 separate groups of 2, and you're going to take out the greatest common factor. So between x squared and 3x, the largest thing that I can take is an x. X squared divided by x. Remember, you're subtracting the exponents. The x on the bottom has an exponent of a 1. So x to the 2 minus 1 is just x to the first, which is just x. And then 3x divided by x. The x's cancel, and you're just left with 3. On the other side, between 1x and 3, the only thing that I can take from both of those is 1. because they don't share anything bigger than 1. So I'm just going to put plus 1, and then if I divide those both by 1, nothing changes, so you still have x plus 3. So one of your factors is the matching term, so the x plus 3, and the other factor comes from the 2 GCFs that were taken out, so the x plus 1. So that would be your factored form. Okay, so these are just a couple more examples. The factor by grouping method is the one where you split the middle term into 2 different terms and then take out the GCFs, and then the box is the box. So I'm going to do it both ways for both of those examples. So factor by grouping, I just realized that we already did the top example on the other page, so I'm going to skip that. I'm going to go ahead to the other example. So factor by grouping for this one, I'm going to start off with my I. A times C goes at the top, and B goes on the bottom. A is 2, B is -5, and C is -7. So A times C is 2 times -7, which is -14, and B is -5. So I need 2 numbers that multiply to give me -14, and add or subtract to give me -5. Those 2 numbers are 7 and 2, and I need this 7 to be negative to get to a -5. So this is the hardest part of factoring, is figuring out what those 2 numbers are. It might take you a couple of tries before you get the right match, but just keep trying until you get it to work out. So I'm going to replace this middle term, and I'm going to break it out into the 2 terms that were in the I. So I have -7x plus 2x, and then I'm just going to bring down the 2x squared and the -7. Then you're going to split this off into 2 separate groups, and you're going to take out the GCF on both sides. So between 2x squared and -7x, I can't evenly divide a 2 out of both of them. The only thing that evenly divides out of both is a single x. So I'm going to do 2x squared divided by x. This x is going to cancel, and there's going to be 1 x left up there. So I'm just going to have 2x to the first power, which is just 2x. And then I'm going to do a -7x divided by x. X's are going to cancel, and you get -7. On the other side, they don't share anything, so I'm just going to put a +1. If I divide both of those by 1, nothing changes, so I'm still going to have 2x minus 7. I know I did it correctly because these are matching. So one of the factors is the matching term of 2x minus 7. The other one are my 2 GCFs, so we've got x plus 1, and that's my factored form. If I were going to solve this, I would take the entire equation, make it equal 0, and then I would break it off and set each of my factors equal to 0. And then you would solve for x on both of them. So I get x equals 7/2. You can just leave it as a fraction. And then I get x equals -1. Okay, if you're going to do this with the box method, it's very similar. Sorry, I'm going to rewrite the problem. What is it? 2x squared minus 5x minus 7. Okay, the 2 factors that we found in our I or negative 7 and 2. So in my box, my very first term is going to go in this box, and my very last term is going to go in this box. The two terms that came from the I are going to go in the diagonals with an X attached to them. Okay, then you're going to take out the GCF along the rows and the columns of the box. So I'm going to go upwards first. 2x squared and negative 7x. The largest thing that they both share is a single x. 2x and negative 7. They don't share anything, so I'm just going to put plus 1. 2x squared and 2x both share a 2x. And negative 7x and negative 7 both share negative 7. So your factors come from the top of the box and this side of the box. So we've got x plus 1 and 2x minus 7. And that's the same thing that we got when we did it the other way. Okay. Yeah, so that completes your notes for today. We will be doing, or you will be doing, a practice assignment tomorrow that involves factoring and solving by factoring. I don't care which method you use. You can either use the grouping or the box method. It's whatever you're most comfortable with, okay? If you have any questions about that, you can email me. I'm going to try to be on my email as much as possible since I won't be there. Okay, good luck.